Exercise 7.3, question number 1. How many 3-digit numbers can be found by using the digits 1 to 9 if no digit is repeated? So let us solve exercise 7.3, question number 1. So solving 1, solution 1. Let the 3-digit numbers be of the form. Let the 3-digit number, let the 3-digit numbers be of the form, be of the form x1, x2, x3, x1, x2, x3. Now, how many digits we can use to fill up this? That is 9. Number of digits available to us. Number of digits available to fill this. To fill this is equal to how many? That is 9. And number of places to be filled up is 3. Number of places to be filled up. Number of places to be filled up. Number of places to be filled up. That is equal to 3. Therefore, how now we'll answer for this one. How many 3-digit numbers can be found by using the digits 1 to 9 if no repetition is allowed? Therefore, number of 3-digit numbers, number of 3-digit numbers, 3-digit numbers which can be formed, which can be formed, which can be formed using the digits 1 to 9, 1 to 9. If no digit is repeated, if no digit is repeated, no digit is repeated, and we know that what is the formula for that? That is NPR. So that is equal to, what is our N here? N is 9, R is 3, so 9P3, and we can simplify it. We can write this as equal to 9P3. We'll apply the formula. This becomes 9 factorial over 9 minus 3 whole factorial. That is equal to 9 factorial over 6 factorial. In this, out of 9 and 6, 9 factorial is bigger, so we can break it up. We can write it as 9 into 8 into 7 into 6 factorial over 6 factorial. Cancelling 6 factorial from both the numerator and denominator, we will be getting 9 into 8 is 72, 72 into 7. So that will be 7 into 2, 14, 1 carried over, 7 into 7, 49, 49 plus 1, 504. So the number of 3-digit numbers which can be found by using the digits 1 to 9 if no digit is repeated are 504. Exercise 7.3, question number 2. How many 4-digit numbers are there with no digit repeated? So solving question number 2, solutions 2. Let the 4-digit numbers be of the form. Let the 4-digit numbers, let the 4-digit numbers be of the form, be of the form x1, x2, x3, x4. And how many digits are there? Number of digits which are available to us are 10, that is 0 to 9. Number of digits available is equal to 10, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And how many places we have to fill? We have to fill 4 places. And number of places to be filled up, number of places to be filled up, that is equal to 4. Now the only problem is with 0. When we put this 0 in x1, then the number will become a 3-digit number. So that is what we'll write here. Putting digit 0 in x1, the number get reduced to 3-digit number. The number x1, x2, x3, x4 becomes a 3-digit number, becomes a 3-digit number. But what is required is only 4-digit number. But what is required is what is required is 4-digit number. Therefore, we can say that here answer of this one, how many 4-digit numbers are there which in which no digit repeated. Therefore, number of 4-digit numbers which can be formed which can be formed with the digits with the digits 0 to 9 with the digits 0 to 9 such that repetition is not allowed such that repetition is not allowed repetition is not allowed and that will be equal to, so if you take 10p4, what is 10p4? 10p4 stands for filling up all the places of, here we have x1, x2, x3, x4. They are 4 places to be filled up, and number of items which are available to fill up them are 10. So filling x1, x2, x3, x4, we will be getting 10p4. So we are getting a 10p4. But already we have discussed that if we fill up this x1 with 0, it will become a 3-digit number. So we'll remove all those kind of numbers. And how many are there? If we suppose we remove out of this one, uh, suppose we take 0 in the first place, then x2, x3, x4 can be filled up in how many ways? 9 ways. And how many places are there? There are 3 places. So that is what we'll do. We'll remove all those numbers. So 10p4 minus 9p3. Why 9p3? Because what we are doing is we are removing the numbers of the type x2, x3, x4 only, which are only of the type x2, x3, x4, because the number has to be 4-digit number. Putting 0 in the extreme left makes no sense, because if x1 is replaced by 0, then x1, x2, x3, x4 become a 3-digit number, not a 4-digit number. So this is our answer, 10p4 minus 9p3. We'll just simplify it and see what we'll get. Solving it, equal to 10p4 means just we'll apply the formula, that is 10 factorial over 10 minus 4 whole factorial minus 9p3, that is 9 factorial over 9 minus 3 whole factorial. So this will give us 10 factorial over 10 minus 4 is 6 factorial minus 9 factorial over, and this will also give us 6 factorial, and we can rewrite this one as 10 into 9 into 8 into 7 into 6 factorial over 6 factorial minus 9 into 8 into 7 into 6 factorial over 6 factorial. So cancelling 6 factorial from both the numerator and denominator, like this, we will be getting here 9 into 8 is 72, and 72 if you multiply with 7, that will give us 72, 14, 1 carried over, 49 plus 1, that is 504. So this will give us 504. So 504 into 0, that is 5040 minus, and this one already we have calculated here, 9 into 8 is 72, 72 into 7, that is 504. So now doing the calculation work in this one further, let us do the subtraction. So this will give us 5040 minus 504. So 1 will carry from here, it will become 10, 10 minus 4 is 6, this will become 3. 1 will take from here, it will become 10 minus 5, that is 5, and it will become 4. So the answer is 4536. So the required answer of question number 2 is 4536. Question number 3. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? So let us do this third one. Question number 3, solving 3. And remember that we can use NPR only when the digits are not being uh, the digits are not being repeated. So question number 3, let the 3-digit number be of the form. Let the 3-digit, it's not 3-digit actually, 3-digit even number. So let the 3-digit even number be of the form x1, x2, x3. Now since it is an even number, that means x3 should be filled up with 0, 2, 4, 6, 8. And here what digits are available to us are 1, 2, 3, 4, 6, 7. So out of that, if you put 2, 4 or 6 in place of x3, it will become a even number. So that is what we'll write here. Since the number has to be even number, the required number since the required number is an even number, is an even number, therefore x3 can be filled up in x3 can be filled up in three ways. That is, we can put in that that is, it can be filled up by it can be filled up by either we can put there 2, or we can put 4, or we can put 6. And first of all, we'll fill only x3. Why? Because repetition is not allowed. Because suppose if we have utilized the numbers 2, 4, 6 in x1, x2 only. Suppose we have used at x1, x2, then only for x3 we'll have only one way. So that is why first of all we'll fill up x3 so that it becomes an even number, because even number is only required by us. We cannot put any other digit in x3 other than 2, 4 and 6. So first of all we'll fill up x3. Now next x2, because here repetition is not allowed. What it says here, third one, no digit is repeated. Since repetition is not allowed, since repetition is not allowed, therefore what we can say that therefore x1 can be filled up in how many ways? Can be filled up in 1, 2, 3, 4, 5, 6. There are 6 ways. Out of that, we have filled up x3. That is in one way. So now one digit has been used in x3. So remaining are now 6 minus 1. That is 5 ways. Can be filled up in 5 ways. And x2 can be filled up in how many ways? One number we have used for, here you can see that one number has been used for x3 and one number has been used for x2. So out of 6, 2 numbers has been used. So 6 minus 2, that is 4. So 4 digits are available which can be used for x2. So x2 can be filled up in 4 ways. Can be filled up in 4 different ways. Therefore, number of 3-digit even numbers available or possible are, therefore number of 3-digit even numbers if no digit is repeated, if no digit is repeated, using the digits 1, 2, 3, 4, 6, 7, that is equal to, so by fundamental principle of counting, 5 into 4 into, and let us see how many ways x3 can be filled up. It can be filled up in 3 ways. So 5 into 4 into 3, and this will give us, we'll multiply. 5 into 4 is 20 and 20 into 3 is 60. So there are 60 numbers, 63 even numbers which are possible by using the digits 1, 2, 3, 4, 6, 7 such that no digit is repeated. Exercise 7.3, question number 4. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4 and 5 if no digit is repeated. How many of these will be even? So solving question number 4, solution fourth one, let the 4-digit numbers be of the form, let the 4-digit numbers, let the 4-digit numbers be of the form x1, x2, x3, x4, and it says that the digits cannot be repeated. Here the digits cannot be repeated. Here the digits cannot be repeated, cannot be repeated. Therefore x1 can be filled up. How many digits are there? There are 5 digits. So x1 can be filled up in 5 ways. X1 can be filled up in in 5 ways, in 5 different ways. Similarly, x2 can be filled up in, because one digit has been used for x1, so x2 can be filled up in. So here 5, and this x2 can be filled up in 4 ways. This can be filled up in 3 ways, and this can be filled up in 2 ways. So x2 can be filled up in 2 ways. Can be filled up in, can be filled up in 4 ways. X3 can be filled up in, x3 can be filled up in how many ways? In 3 ways. Can be filled up in 3 ways. Similarly, x2 can be filled up in 2 ways. X2 can be filled up in, x2 can be filled up in, can be filled up in 2 ways. Therefore, number of 4-digit numbers which are possible, therefore number of 4-digit numbers, number of 4-digit numbers which are possible, which are possible when repetition is not allowed, when repetition of digits is not allowed, when repetition of digits is not allowed, repetition of digits is not allowed. So that will be equal to, in how many ways we can fill up x2? There is 5 ways, x2 in 4 ways, x3 in 3 ways, and x2 in 2 ways. So by fundamental principle of counting, we just simply multiply them, 5 into 4 into 3 into 2. So that will give us 5 into 4 is 20, 20 into 3 is 60, 60 into 2 is 120. So there are 120 digits which are possible under the given condition. Now we have to check that how many of these will be even. So going for the second part, fourth one, second part. So same way, let the 4-digit number, let the 4-digit even number, let the 4-digit even number be of the form, be of the form x1, x2, x3, x4. Now here repetition is not allowed. Here repetition is not allowed. Repetition is not allowed. So what we'll do, because the 4-digit number has to be an even number. So first of all, we'll fill up x4. We'll fill up this x4. So since the required number is even number, since the required number is even, therefore we'll fill x4 first. We will fill x4 first. And in how many ways we can fill up x4? X4 can be filled up in, here what the number we are having is x1, x2, x3, x4. Now first of all, we'll fill x4. So what are the digits available to us? They are 1, 2, 3, 4, 5, but we have to make it even, so we'll fill only 2 and 4. So x4 can be filled up in, so x4 can be filled up in only 2 ways. X4 can be filled up in 2 ways. Then we can fill any of these x1, x2, x3. So let us fill up x1. X1 can be filled up in in how many ways? So 1, 2, 3, 4. So here we have 5 digits: 1, 2, 3, 4, 5. Out of that, one has been used up for x4. So remaining are 4. So x1 can be filled up in 4 ways. In 4 ways. Then x2 can be filled up in 3 ways. Then our x3 can be filled up in 2 ways. Therefore, required even numbers, required even 4-digit numbers, 4-digit numbers when repetition is not allowed. So when repetition is not allowed, when repetition is not allowed, and that will be equal to, we'll be using the fundamental principle of counting, that is equal to, first x1 can be filled up in 4 ways, then x2 in 3 ways, x3 in 2 ways, and x4 again in 2 ways. Here we have seen that x4 can be filled up only in 2 ways, so into 2. So this will give us 4 into 3 is 12, 12 into 2 is 24, 24 2 into, that is 48. So the number of 4-digit numbers are possible by using the digits 1, 2, 3, 4 and 5. Question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So in solving question number 5 now, solution 5. Here number of persons are 8, so here n equal to 8. And how many positions are there? One is of chair and one of vice chair, so total 2. R equal to 2. Therefore, the number of ways in which one can hold the position is, therefore number of ways in which a chairman and a vice chairman can be selected. Number of ways in which a chairman and a vice chairman can be chosen is equal to, that is NPR. So 8P2. So that is equal to 8 factorial over 8 minus 2, that is 6 factorial. So that will give us 8 into 7, that is 56. So in 56 ways, the chairman and vice chairman can be selected. Now solving question number 6. Find n if n minus 1 P3 ratio np4 equal to 1 ratio n. So solving question number 6. N minus 1 P3 over np4, that is equal to 1 by 9. So applying the formula of NPR, we will be getting n minus 1 factorial over n minus 1 minus 3 factorial, and ratio, this will become n factorial over n minus 4 factorial equal to 1 ratio 9. And here this is n minus 1 minus 3. On solving, we will be getting n minus 4 factors. So both can be cancelled out. These two can be cancelled out. So what we will be getting here is, this implies n minus 1 whole factorial over n factorial equal to 1 by 9. This implies further. Now out of this n minus 1 factorial, n factorial is the bigger one, so we'll split it. So n minus 1 whole factorial over, writing n factorial as n into n minus 1 whole factorial equal to 1 by 9. So from both the numerator and denominator we can cancel out n minus 1 n minus 1 whole factorial. So cancelling out, we'll be getting, just we'll do cross multiplication and we'll get n into 1 equal to 9. That is, therefore n equal to 9. So the answer of question number 6 is n equal to 9. Exercise 7.3, question number 7. Find r if 5p r equal to 2 into 6p r minus 1. So solving question number 7, first part. So 5p r is equal to 2 into 6p r minus 1. Applying the formula of NPR, we will be getting here 5 factorial over 5 minus r whole factorial equal to 2 into 6 factorial over 6 minus, in bracket, r minus 1 whole factorial. So this will give us 5 factorial over 5 minus r whole factorial equal to 2 into 6 factorial over, on opening this we will be getting 6 minus r plus 1, that is 7 minus r whole factorial. Now if you see in the left hand side and the right hand side, in the numerator we can see that 6 factorial is bigger than 5 factorial, and the same way in the denominator 7 minus r factorial, 7 minus r whole factorial is bigger than 5 minus r whole factorial. So 5 factorial as it is, 2 into 6 factorial we can write as 6 into 5 factorial, and in the denominator this is 5 minus r whole factorial, and to the right hand side we can write it as 7 minus r into 6 minus r into 5 minus r whole factorial. Now both sides in the denominator we can cancel out 5 minus r whole factorial. Then in the numerator we can cancel out 5 factorial. So simplifying it further, we'll be getting 7 minus r into 6 minus r equal to 6 into 2, that is 12. So simplifying it, we'll get 7 into 6 is 42 minus 7r minus 6r plus r square equal to 12. So rewriting this, we'll be getting r square minus 13r plus 42 equal to 12. R square minus 13r, this will become plus 30 equal to 0. Now splitting the middle term, and the middle term is negative, so 30, if you multiply the constant 30 with the coefficient of r square, we will get 30 into 1, that is 30, and 30 we can write as 30 equal to minus 10 into minus 3. So when we multiply we get minus 30, and adding them we get minus 13. So we'll rewrite the middle term as r square minus 10r minus 3r plus 30 equal to 0. So taking r common from the first two terms, we'll get r into r minus 10. Then taking minus 3 common from the next, from the third and fourth term, we'll get minus 3 into r minus 10 equal to 0. Therefore, r minus 10 into r minus 3 equal to 0. And solving this, we will be getting r equal to 10 or 3. Now, here we know that since r is always less than or equal to n, therefore r equal to 10 is not possible. R equal to 10 is not possible. So only possibility is that of, therefore r equal to 3. So this is the answer of question number 7th one, first part. Exercise 7.3, question number 7, second part. That will be for self trial, and you will be doing in the same way as we have done the first part. So that is for self trial. And this question number 8 also is a very simple one. How many words with or without meanings can be formed using all the letters of the word equation? So if you see the word equation, it is filling how many places the letters are filling: 1, 2, 3, 4, 5, 6, 7, 8. So it is occupying 8 places. So that means the here number of letters which are available to us are 8, and also the number of places to be filled up are 8. Therefore, the number of words which are possible with or without meaning will be 8p8, that is 8 factorial. So let us do this eighth one, solution number 8. Here the letters of the word, here the letters of the word equation, they occupy 8 places. They occupy 8 places, and number of letters also 8, and number of letters are, because they all are distinct, no letter is being repeated. Number of letters are 8, as no letter is being repeated, so therefore no letter is being repeated. Therefore, number of words which are possible with or without meaning, which are possible with or without meaning, that is equal to 8p8. Why 8p8? Because there are 8 places to be filled up and there are only 8 letters. If you see here equation, no letters being repeated, so that means n is 8, also r is 8, because they are occupying 8 places. So 8p8. If you apply the formula of npr, we will be getting 8 factorial over 8 minus 8 factorial, and that is equal to 8 factorial over 0 factorial, and this will give us equal to 0 factorial is 1, so it will become 8 factorial, and this is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, and this can be written as 3 into 2 6, 6 into 4 24, 24 into 5 is 120, 120 into 6 is 720, 720 into 7 to 8 is 56, so we'll write it as 56 into 720. So this will give us equal to 72. Let us multiply with 56. So 6 into 2 is 12, 1 carried over. 7 into 6, 42, 43. Then 5 into 10, 1 carried over. 7 into 5, 35, plus 1, 36. So adding up these, now we'll get 2, then 3, 6 plus 4 is 10, 1 carried over. 4032, and 1 0 is here, so this will become 40320. That means there are 40,320 words which are possible by using the letter of the word equation, which have meaning or may not have the meaning. So this is the answer of question number 8.